in 5.3. So this is the start of 5.4 here, and we're answering present value, which is a little different than the other ones. So how do you do present value of an ordinary annuity? Now let me help you with these two different sections and how they're similar and how they're different, because this can be kind of confusing. In the end, it's just going to be a big old formula. Hit the buttons on your calculator, kind of the same. But what's hard on the test is distinguishing one from the other. So let me start that even now. In 5.3, we did the last section, last time, the homework that was due today. Future value of what's an annuity, by the way? Annuity is a series of payments, right? It's a series of, we're all on the screen there, yeah. Series of payments. So both of these, yesterday or whatever, last week, and today are both annuities. So 5.3 was the future value of annuity. That means like if you're doing payments and it gets bigger, 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 until a big pile in the future. That's future value. See how the pile's in the future? So that would be like saving for retirement, for example. You're just putting money away every month, big old pile at the end. Future value. You want a big old pile in the end so you can retire. That was the last section. That was 5.3. So this one, 5.4 today, is present value of an annuity. So it's still an annuity. It's still a series of payments. But we're talking about the pile being now, in the present. So it's a big old pile now. And what we're going to do is we're going to pull off this pile. So what's that? Well, that'd be like after you retire. You save up your money, save up in a big old pile, and then you take your retirement. You quit your job, and then you start pulling off of that pile, huh? You have a big old pile, you pull some off, you pull some off, you pull some off, you pull some off. You hope it doesn't run out before you die, right? You have money all the way to the end. So that's present value. That's a different kind of thing. The pile is now, and you're pulling off the pile. So taking out retirement money. So, after you retire, paying yourself out of your big old saved up bank account when you retire. Or, what else this is like? A home loan or a car loan. That'd be another typical way we do present value. Why? Well, because when you buy a house or buy a car, if you get a loan for the car, do they give you the car later or now? Well, they give you the car now, which means really your bank paid the car dealer now. They gave the big old pile of money straight away to your car dealer. Or when you buy a house, the bank paid the builder of the house or the people you bought the house from, right? They paid them now. So in a sense, you have the pile now. You have the house now. You have the car now. You've been given the money by the bank. The bank paid directly to the builder of the house or the people you bought it from or the car maker. Now, and what are you going to do? So right now you owe the bank a big old pile of money for the car or the house you bought, and you're going to what? Pay them, the amount you owe them, you're going to break it down over time until it's all gone. That's the same thing. There's a pile now that you owe, and with the retirement, there's a pile now that you have. Whatever, same thing. Pile now, we're going to break that pile down over time. Does everybody see the difference between? I'll be pointing it out as we go. So it's all about, you want to think, it's all about whether that pile's in the future or that pile's now. That's how you know whether it's the 5.3, the formulas we use then. You'll have them all on your 3x5 card, You don't need to memorize any formulas. You'll have them all with you. In fact, I even put them all right at the top of the exam. You'll see on the practice exam, I put them all right up there. So you don't even have to write them on your 3x5 card. You'll have all the formulas. It's just about identifying one word problem from the other. And here's the main question. Is the pile in the future? Like I'm saving up for retirement later? Or, I had a new child born, I'm saving up for their college education later? Pile later? Or is the pile now? Like I bought a house or I bought a car, I owe a big pile now, and I'm going to break down how much I owe over time and finally pay it off. I'm excited. This summer we're going to finally pay off our car. 5 years, finally. Anyway, so that you break down until finally you paid the thing off, or taking your retirement. Big old pile of money you start taking from the pile, breaking the pile down. Okay, so you see this one? Find the present value And so I'm going to use a different formula. This is present value, which means pile now. So what's the present value formula? It is, here's the present value, it's P equals R, so present value P equals R. It's kind of like the other one. I mean, they're all sort of similar. 1 plus R over N to the negative NT, it's a little weird, over R over N. There we go. So there's the formula for present value of an annuity. That's the 5.4 formula that we're going to use a whole bunch now. All right, so then it's just a matter of using that thing. And all the rest of the stuff is pretty much the same. You know, payments 420. Where's the payments go? Yeah, right there. Boom. Put it in for R. 13 years. That's your T. 6%. You know that's your R. Compounded annually. What does that mean? N is 1, huh? So let's plug everything in. So we get 420. 1 minus 1 plus R, which is 0.06 over N. That's a 0.06 there. Whoops. Over N is 1 to the minus N times T is 13 over R over N, 0.06 over 1. Is that okay? Get a little scribbly there. Can you read all that? This is a 13 up here. It's like a B. We good? So there it is. So remember how to do these on your graphing calculator. Are you getting good at that? So I would start right in here in the middle. I was trying to give you an easy way to use your graphing calculator. I would just start right in there in the middle, and I would just say, so on the calculator, I would just go 1 plus 0.06. You don't need to go divided by 1, right? That doesn't do anything. And then I would just hit enter, which is really just 1.06, to the power of negative 13, enter. 1 minus answer. Remember the answer key, which is right above the negative button. 1 minus answer. Enter. Is everybody seeing what I'm doing? So the first step, I do the 1 plus 0.06, which is that inside. I do it to the power negative 13. And then I take 1 minus this whole answer. Everybody see that? 1 minus the answer, enter. And then I divide that whole thing by 0.06. This is just 0.06. Hit enter. And I go times 420. Enter. And I'm hoping that comes out A, because A is what it said the answer was. Is that right? Comes out that way. Let me do it myself just to verify. To the power negative 13. 0.06. Oops. To the 1 minus. You guys able to find the answer button? It's right above the negative at the very bottom of the calculator. I'm getting 3718 13. Yep, exactly what they got. Is that good? Is that okay on that? Questions on that? So what does that mean? That means if you have a pile $3,718.13, if you have that big of a pile and you want to take off of that pile, or like say you bought a car for $3,718, you're going to have to make payments back on that of $420 a year. I guess you don't make car payments every year, but whatever. $420 a year for 13 years at 6%. If you did that all that time, it'll finally wear down that pile to nothing. Good questions I can answer. So that's our new formula. I give you all of them right at the top of the test. So the main thing for you would be identification, you know, when they're all mixed up on that. And we'll practice that as we go. All right. Okay, there we go. So present value. So the key words, you see present value. You think, oh, the pile now in the present, not future. I'm not storing up for a big pile later. There's a big pile now, like a loan, a car loan, or a house loan, or I just retired and I've got a big pile in the bank and I'm taking away from that pile. Pile is in the present. So we use the present value formula, which again, these will be right at the top of the test. I started working this weekend on your next exam and on the practice exam that goes with it. And all four of the, I think there's four of those are right at the top of the test. Right above number 1. They're all up there. All these different formulas. I think we have 4. Didn't we have 2 from last section? We're just going to have 1 in this section. Just 1. Didn't we have, we had from the last section, 5.3, we had the one where the payments were at the end and then the one at the beginning, right? We had those 2. So those 2 are there. This one, we're not going to do the 2 versions on it. We're just going to do the 1 version on this one. And then we had that other one, the compound interest, A equals P, 1 plus R over N to the NT. That one will be there too. Those 4 formulas are right at the top. You'll see on the practice exam. So try that one. So feel free to compare with those around you, see if you're getting the same answer. Somebody got an answer already? Not yet? Okay. Let's see. So it's payment 17, 146. 1 minus, what is it? 1 plus R over N. R is 11. R is 0.112, right? Over N. What's N? Semi-annually, twice a year, N is 2. Minus 2, and then T is 10 years, all over. There we go. So start typing that in. What can you do with this fraction? Remember we talked about that fraction on the bottom, an easy way to handle that thing? Remember that? Fraction on the bottom, you can just flip it upside down and just go times. Or just, I'll get rid of the X might confuse you. Just multiply by the upside down. Remember that? When you have a fraction on the bottom of a fraction, you can just flip it up and multiply. Because dividing is upside down multiplying, isn't it? Dividing and multiplying are just upside downs. You guys with me? I'm not seeing a lot of nodding. Yeah, I remember that, Mr. Heron. No? Do you remember that? Remember that? So you take, that'll make it easier. The reason I did not do that on the quiz one we just did is because it was easy. It was just over 1. Where was it? Here. See, it just had a 1. So, I mean, you don't need to do it. That's just 0.06. No need to do anything fancy when it's just got a 1. But this one's a little harder. That it can mess you up. So I would grab that fraction and just flip it upside down and multiply. So, because dividing is upside down multiplying. So instead of dividing by this, just multiply by the upside down. So type that into your calculator. So I would start right in the middle. I'd start right here. So let me write out what I would do in the calculator. So on the calculator, I would go 1 plus 0.112 divided by 2, enter. Is that all on the screen? Yeah. And then I would go to the power of negative 20, enter. 1 minus answer key, enter. And then go times 2 divided by 0.112, enter, and then go times 17,146, enter. Is that working for you? So, and I'm getting 203,211.96 when I rounded in the nearest cent there. That's how big the pile would have to be in the present, 203,000, to pull off those payments for 10 years. Y'all getting that? Questions I can answer? You okay with the calculator steps over here? It's making sense. How to do the calculator. Good with the answer key and all that kind of stuff. So that just makes it easier. We don't have to worry about tons of parentheses, and all that weird stuff. Questions? All right, I'm going to move ahead. 3 or 4 problems are just cookie cutter all the same. So now, yeah, first three are. Now number 4 says find the payment. We're still dealing with the same formula because it says present value, ordinary annuity, present value. So we're still talking about pile now, present value, not future value, which was the last section. So that's how you would recognize it on the next test. You go, oh, present value, pile now, use that formula, which will be right at the top of the test. You go, okay, I'm still talking about the same formula. Okay, still talking about that formula. So let's see, what are we doing? So, but there's a little different approach. They're saying find the payment, which is R, huh? I'm going to find R. So that means this 83,000 thing is not R. What is it? That must be the present value with the given present value. This is the present value. It's not R, because they're asking me to find R, aren't they? So that's the 83,678. I don't know R. And then what about the rest of it? What's the R, the rate, the R, the little r is 0.059 over N. In monthly, what's N? Could be 12? Yeah, monthly N is 12. To the negative 12 times T. T is 16 years. All over 0.059 over 12. So there we go. We have to solve that for R. Don't we? We have to get R alone there. So what are you going to do to get R alone? Divide by that big old bracketed chunk, don't you? Does that make sense? So you got to divide both sides by that big old bracketed chunk. So go ahead and do that. You doing okay? So let me get a fresh screen. I'm kind of out of room to divide that thing. Get a fresh screen here. Where were we? 83,000. Okay, so it was 83,678 equals R, and it was 1 minus 1 plus 0.059 over 12 to the minus 12 times 16 over 0.059 over 12. Okay, so to solve that thing, we divide both sides by that entire, and we got to do it on both sides, don't we? By the entire bracketed mess. So it's going to be 1 minus 1 plus 0.059 over 12 to the minus 12 parentheses 16 over 0.059 over 12. That's right, same. Right? Big old mess. That's how we solve for R. We just divide both sides by that big old mess. So you got to somehow do all of this on your calculator, huh? So let me lead you through the calculator steps. Where do you start? I always start right here in the middle, don't I? Doesn't matter. It's on the bottom, whatever. Just be totally easy. Just go 1 plus 0.059 divided by 12, enter. You with me? So now I have the answer to this. And then I just go to the power, to the power, now 12 times 16. Know what it is? You might want to figure that out first. Yeah, I'd probably figure this out and go, oh, this is negative 192. To the power, negative 192. Now, you might say, well, Mr. Ryan, can't we just do it right here? You could, but remember, if there's ever more than one, the main thing to remember with the calculator, if there's ever more than one thing in a zone, what do I mean by zone? Numerator, denominator, or power. Zones. Those are 3 zones, right? If you ever have more than one thing, like if I was just to go raise it to the power of negative 12 times 16, it wouldn't work. It'd be the wrong thing. Why? It would only raise it to the first thing. It would just go to the negative 12, like it would just go whatever, blah, blah, blah. Oops, where's my blah, blah, blah? It would go blah, blah, blah to the negative 12 and then multiply by the 16 in the front. It wouldn't know the 16 is also in the power zone. Unless you what? Put an extra set of parentheses. Then it will know, oh, they're both part of the power thing. Then it would put them both. So you could either do that, or if that's kind of confusing, just figure it out ahead of time. It's negative 192. Just raise it to the negative 192. Does that make sense, guys? That's the main thing that would trip people up. Whenever there's more than one thing in a zone, numerator, denominator, or power, you've got to put parentheses around the whole thing, an extra set, to tell the calculator both these things are up in that world together. Otherwise, it'll only do the first thing. It doesn't know what you mean. It can't read your mind. It's not very smart. So we do that, and then we go 1 minus, hit the answer button, and now we've got the whole numerator, don't we? Got the whole numerator, and then we go do, oh, and then remember my trick? You take this, well, if you want, you could just go divide by, but you're going to have, here again, you're going to have to parenthesize. If you want to do it like that, you see you're going to have to parenthesize those because there's more than one item in the denominator, huh? That's why I do the trick where I flip it up and multiply. But if that's bugging you, just divide, but you got to put them in parentheses. If you don't put these parentheses, it'll only divide by the first number. And then the second, it'll do something, it'll divide the whole thing by the 12. It'll do something different. Does that make sense? If you have more than one thing in the denominator, numerator, or power zone, on one step, that is, I'm breaking it into several steps so we don't have much of that to deal with. But if on one step you're dividing or multiplying or powering by more than one thing, parenthesize. So it knows you're dividing by both those. Like that, hit enter. Now, what do I have at this point? At this point, I have all of this denominator, don't I? So then you just go 83,678 divided by answer. Enter. And you get it. Was that good? Does everybody see that? So let me go through that with you. I'm getting 674.42. Those are the payments that must be made every month to do that pile. Or to reduce that pile. That was a present pile. To reduce that pile, 674.42. Is that coming out? You okay with the calculator steps? Again, the key is if on any one of these steps you're multiplying or dividing. See, I didn't care about the adding. Who cares? But if you're powering or dividing, multiplying by more than one thing, you got to parenthesize it. See how I went step by step and just made it easier that way? Use the answer button. Question, comment?
So you would still get the same answer if you decided to multiply.
Instead of the divide by these guys, you multiply by the upside down?
Yes.
Totally.
Okay.
Same thing, yeah, because dividing is upside down, multiplying.
Okay.
Be totally the same. All is well? All right. Formulas and hitting the buttons. It needs to be somewhat real. Let me help you. This is an easy enough one where we can kind of make it real. Think with me for just a second. We want what lump sum, what big pile today is needed so that we can produce payments of $11,000 each year for 12 years. You think, oh, you want $11,000 each year for 12 years? It's just $11,000 times 12. That's not right. What would the answer be? It would be $132,000. That's all you need. Put $132,000 in the bank, and that'll be $11,000 for 12 years, every year for 12 years. Why are we doing all this fancy math stuff? Just multiply. What's wrong with that?
We're forgetting the rate.
Yeah, the fact is, there's interest rates. So what? What's that going to do? So you tell me. Just set aside the math, the formula. Just think real life. The fact that the money the big pile that you put in the bank, it's going to be growing because of the interest, but shrinking because you're pulling off payments every year. You see the dynamic that's happening? You put a big pile in the bank starts paying you interest, so the pile starts growing, but then every year you pull off 11,000, pull off 11,000, you shrink it. So the pile is growing because of interest, but shrinking as you pull off 11,000 every year until at the end of 12 years, exactly the last 11,000 is pulled off. So that's what they're asking. It's not just simply 11,000 times 12. So you tell me, guys and gals, will the real answer, please stand up, will the real answer be bigger or smaller than that 132,000? Is it really bigger? Do you really think with me real life? Because if I took $132,000, remember right after the Great Depression, how everybody stopped using banks because they were afraid of them? I don't blame them. I probably would too if they took all my money and I'd be nervous of banks. Anyway, and stuck them in their mattress. So if I took $132,000 and stuck it in my mattress, be very comfortable. $132,000 stuck in the mattress so that it knows no interest, I'm saying, and just pulled off 11,000 every year for my retirement. Okay, now think, what if one of my kids came to me and said, "Dad, what are you doing? Put that money in the bank, you'll get some interest." So what I need, if I agreed with my kids and put money in the bank, would I need to put a bigger pile in the bank than before, now that they're paying me interest? Or a smaller pile? Smaller. Do you see the real answer is smaller? Because a smaller pile, now with interest, will grow. It's not going to be a lot smaller, but a little smaller, maybe 120, we'll figure it out. Do you get the idea? Do you feel it in your gut? That it's a smaller pile because it'll grow to be 132,000 because of interest over time as things are pulled off and all that. Do you get the idea? It allows you to put a smaller pile in, and the interest makes it grow. That's so that in the end you're going to pull off 132. You're going to pull off 12 payments of 11,000. You're going to pull off 132, but you didn't have to put 132 in at the beginning. You put in lower than that, and it grew to be that over time in various stages of piles, right? That's why it's kind of a complex formula. All right, I just want to give you a feel for that. Let's actually calculate it and see that it's a little smaller. So it's present value R, the whole thing. What is it? 1 minus 1 plus R over N to the minus NT all over R over N. Okay, so here we go. So it's going to be, what's the payment? 11,000 times 1 minus 1 plus. The interest rate is 9%. And it's once a year, huh? And it's just one for 12 years. Right? I'm not missing anything, right? And then 0.09. So it's an easy one. So, yeah, so there we go. Just crank it out in your calculator. Let's see what we get here. I'm getting, wow, it's a lot smaller. What did I say, 120,000? I have no feel at all. I get 78, 767, 90. That's almost unbelievable. Did you guys get that?
Yeah.
That's amazing, isn't it? Think about that. That's why Einstein called compound interest the seventh wonder of the world. That's what this money's growing by compound interest. So all you got to put under 80,000. You're going to pull off 132 over the years. Because that 78,000 whatever will grow with interest. Even though you're pulling some off every year, most of it is left in there for most of the time, and it grows, and you end up pulling off $132,000. You only put 78 something in the bank, but the interest carried it through so that you could eventually pull out 132,000. So you can see it pays to be careful with money and wise and think about interest rates and all that. It really does pay, doesn't it? All that stuff they say, pay off your house quick and da-da-da-da. Anyway, I'm not a financial guru by any means, but I'm just saying, hey, look at those numbers. They're kind of weighty, aren't they? So if I stuck the money in my mattress, I just lost over $50,000. I had to, I could have gained. The gain in interest was over $50,000, Like almost $54,000 almost, huh? In interest. That's a lot. Good? This all making sense? Amortize. So I'm trying to help you. A lot of this game on the next test will be the recognizing the words. What does amortize alone mean? Anybody know already? You guys are the business people. I'm thinking, aren't you mostly business majors? What does it mean to amortize a loan? Do you know, my English teacher in senior year in high school, she made us memorize tons of prefixes and suffixes. It felt like torture at the time. But she swore that would help us know a lot of words, and she is right. I'm still thankful for her. Do you know what mort means when it's on a word? Mortality. What's that? Yeah, mort means life. And what is a mort? And what's a in front of a word? Not life. Death. To amortize a loan means to kill it. So when you talk about amortizing a loan, you mean kill it, which is what I'm happy to do this summer when we finally pay off my car for 5 years. So we have this big pile we owed the bank, and we're working on it. We'll finally kill it this summer. So that's what they mean. So when you see the word amortize, you think big pile now, pay it down until it's dead. We love it when a loan is dead. I love it when the pink slip shows up in the mail and it's finally my car. In 8 years, 7.5 years, supposedly I'll actually pay off my house. That seems like a dream that would never happen. That must be a day when you get them in the mail. My friend just did it like 2 months ago. He just paid off his house. It's like, wow, what's that like? You actually own your house? Anyway, so those are all amortizing a loan. You're killing it until it's all paid off. So when you see those words on the test, you'll think, oh, that means pile now, and I'm killing it off. So think, oh, well, that's just fancy words, again, for the present value, right? So amortizing, you can just put it on your 3x5 card if you want. Anytime they say amortize a loan, it means present value. There's a pile now, you're killing it down. So you would use the same formula, which is, P equals R, 1 minus 1 plus R over N to the minus NT over R over N. Same thing. If you amortize a loan, you means you kill a loan. Find the payment necessary to kill this loan. Can I just move on now that you know that? Let's go to something harder. I'm just mainly want to show you. Amortize means present value. You're killing a loan. Because you have the car now, you have the house now, you owe the bank a whole bunch of money now, and you're killing off that loan. All right. So on the next exam, if I give you a house payment or a car payment problem, it's present value. Because it won't say, you won't look up and go, oh, I'm in the present value section. That part won't be there, right? It'll just be a test question. And you'll know, oh yeah, house payment, car payment. You just write that right in your 3x5 card. House payment, car payment, present value, for sure. It's always that. All right, so it's write it up here. It's P equals R, same formula it's been for the last few minutes. R over N to the minus NT, right? I'm starting to get it memorized. Over R over N, you probably are too. Okay, so there it is. So let's plug in stuff. Now we're trying to find the monthly payments. How do they calculate that monthly payment? Well, what they're doing is they're calculating what it'll take every month to kill that loan off over, 20 years, 30 years, 15 years, whatever. So let's figure it out. 135,200. Where's that go? They're saying find the payment. So I'm finding R.
So that's the P.
So this must be P. That's the pile. That's the pile we owe the bank right now. 135,200 is R. 1 minus the interest rate, 0.048. Oops, got the 1 plus, huh? Over N, 20 years. No, not 20. What am I doing? What's N? 12 monthly, huh? Yeah, N is 12. N is 12 for monthly. Times 20 years. All over 0.48 over 12. So there we go. So we want to solve for R, the payment. What kind of payment will kill that loan over 20 years? Will kill that pile of debt. So how are we going to solve for R there? Going to divide by that whole gigantic bracketed thing, aren't we? So divide by. Good there. And then on your calculator, can you write down the steps to figure out all of that? So start it here in the middle. 1 plus 0.048 divided by 12. Enter. To the power, parenthesis, negative 12 times 20. And to remember, more than one thing in the power zone, more than one thing in the denominator, you got to parenthesize both those things to tell the calculator they're both together in that zone. All right, so let's see what we get. I'm getting 877.39. Y'all getting that? So that's the house payment. 877.39 per month will kill that loan over 20 years. That making sense? Hey, by the way, could we figure out how much we're actually paying for the house? This is always a shocking calculation. $877.39 per month. 12 months in a year, 20 years, right? So if we just multiply that by 12 months every year, that's how much we're paying per year, times 20 years, we'll get the total amount paid, right? They didn't ask me to do this, but it's always interesting and shocking. I'm getting $210,575. No, 573, huh? 60. That's the total paid. What was the price of the house? 135. How much did we pay for the house? Almost double. What's all that extra? Interest. You could subtract those and you'd get how much you gave as interest. That's why. That's a lot, right? That's what is that? 75,000 in interest, about a little over 70, just 75,300 something. $75,000 in interest. And that's only a 20-year loan. Most people get 30-year loans, right? Me too. I mean, I'll probably end up 2025 when it's all done, but yeah, and you pay for the house more than twice, sometimes 3 times. It depends on your interest. That's actually a low interest rate, pretty low, and not that long of a time. If you have like a higher interest rate in 30 years, you're paying for the house like 3 times over, twice for interest, once for. So the point of the matter is, it helps a lot. So if you're a homeowner, going to be in the next 5 years or whatever, if you can pay. That's why they say, and they're right. Let me tell you, as a math teacher, they are right. Who say just pay a little extra if you can. Just a little bit, $100 every month, kills that loan quicker, saves you thousands of dollars in the end. Really saves a lot of money because basically the longer you let that pile sit out there, the bank is charging you interest on what you owe them all the way along. So you want to kill that pile as quick as you can because they're just taking interest from you until that pile's dead. But, you got to live life too, so there's a balance. To get rid of the pile eventually, it's the same thing. Except credit cards are 18%. That's like highway robbery. You got to put your hands in the air when you make that payment. That's just terrible. Hey, you shouldn't pay 18% on anything if you can avoid it. They're just taking your money. They're just taking it. So 98.70, 18%. So it's the same thing, right? I'm just going to go ... Same formula. I better get to the next section. So I'm going to move on if that's okay with you. It's the same formula. It's just P equals R, 1, what is it? Minus 1 plus R over N. Maybe I'll do the first plug-in step and just stop there. Minus NT over R over N. Same exact formula. How would you recognize that? Because that's the pile now, isn't it? Present value. Present value, pile now. You owe the credit card company now. You owe for the car now. You owe for the house now as pile now. So the 98.70, what is that? Is that the P or the R? Silence. A hush fell over the room. Well, you can tell me they're what are they asking for? Yeah, somewhere it says, I can't even find it now.
This is A.
What monthly payment? Yeah, A. What monthly payment? So this is P, isn't it? That's the pile. That's the pile. That's what he owes the credit card company. So and then the interest rate is a whopping 18%. Monthly, so that's 12. And 2 years over R over N, 0.18 over 12. There we go. You got to divide by that and solve, and it'll be some awful amount of payment. Anyway, so I'm going to move on. If you're okay with that, I'm going to move.